The first formation of P-47 Thunderbolts that Hauptmann Klaus Richter encountered over Western Germany in March 1944 moved with systematic precision that seemed to mock every assumption about American aircraft production and pilot training capabilities. The veteran Luftwaffe pilot, credited with 89 aerial victories, found himself facing wave after wave of American fighters that appeared in numbers exceeding his squadron's entire aircraft inventory. "Where do they get all these pilots?" Richter radioed to his wingman as the 15th P-47 formation of the morning approached German airspace. "We shoot down 10, 20 appears. We destroy 50, 100 arrives. It's as if they manufacture pilots faster than we can eliminate them." These were experienced German aviators who understood aerial warfare through years of tactical superiority and technological innovation that had dominated European skies since 1939. They had calculated Allied pilot training requirements, analyzed aircraft production capabilities, and developed mathematical models proving that quality would triumph over quantity through superior skill and systematic excellence. They had no way of knowing they were facing the most massive aviation training program in history, or that American factories would produce over 15,000 P-47 Thunderbolts, while training systems graduated pilots faster than German forces could eliminate them, fundamentally overwhelming Luftwaffe capabilities through systematic abundance. Hauptmann Klaus Richter adjusted his oxygen mask in the cockpit of his Messerschmitt Bf 109 G6 as his squadron prepared for morning interception duties over the Rhine, confident that German tactical superiority would continue overwhelming Allied aviation despite increasing enemy activity. As a veteran with 89 confirmed victories, Richter embodied Luftwaffe excellence through systematic training and combat experience that had dominated European aerial warfare. The German pilot training system that Richter represented included extensive flight instruction, advanced tactical education, and combat experience that created aviators with thousands of flight hours before their first combat missions. Luftwaffe academies produced pilots through systematic programs emphasizing individual excellence and technological mastery that seemed impossible for rapidly expanding Allied air forces to match. Tactical doctrine that guided German fighter operations emphasized individual pilot skill, aircraft performance advantages, and systematic coordination that maximized combat effectiveness through superior training and technological innovation. German fighters engaged Allied aircraft through proven methods that had achieved remarkable success throughout European campaigns. The aircraft technology that German pilots operated included sophisticated engineering, advanced weapons systems, and performance characteristics that exceeded Allied fighters in most combat categories. Messerschmitt and Focke-Wulf aircraft represented German industrial excellence through precision manufacturing and systematic development that created tactical advantages. Combat statistics from 1940 to 1943 validated German assumptions about aerial superiority, with experienced pilots achieving remarkable kill ratios against Allied opponents while demonstrating consistent tactical dominance. These mathematical results seem to prove German aviation superiority through measurable combat effectiveness. Intelligence analysis of Allied aviation capabilities suggested enemy forces remained limited by conventional training methods, resource constraints, and industrial limitations that prevented rapid expansion of qualified pilot strength. German planners calculated that Allied aviation would face systematic pilot shortages that tactical excellence could exploit. The strategic doctrine that incorporated pilot quality advantages assumed German aerial superiority would maintain defensive effectiveness through individual excellence overcoming numerical disadvantages. Quality appeared more decisive than quantity in aerial combat, where pilot skill determined tactical outcomes. International recognition of German aviation achievements included professional acknowledgement from enemy forces, who documented Luftwaffe tactical superiority and technological innovation. Allied respect for German aviation validated confidence in continued aerial dominance despite numerical expansion. Economic calculations performed by German aviation commands revealed Allied training costs and resource requirements that suggested unsustainable pilot production rates. German analysis indicated enemy aviation expansion would collapse under training demands and resource limitations. The psychological foundation of Luftwaffe confidence included systematic belief in individual excellence, triumphing over mass production approaches that allegedly sacrificed quality for quantity. German pilots viewed combat as proving individual superiority rather than industrial capability. Training infrastructure within German aviation included advanced facilities, experienced instructors, and systematic programs that created pilot competence through proven methods emphasizing technical mastery and tactical innovation. Educational excellence supported continued aviation superiority. Resource allocation within Luftwaffe operations prioritized pilot training. Quality over quantity production, reflecting confidence that superior aviators would achieve victory through tactical excellence rather than numerical advantage. Individual excellence justified resource investment. The tactical confidence appeared mathematically certain based on proven combat effectiveness and systematic training advantages that had established clear German superiority in aerial warfare. This confidence would soon face unprecedented challenges from American aviation capabilities that exceeded every calculation of democratic training potential and industrial aircraft production. Colonel William Kepner stood at the controls of a P-47 Thunderbolt at Farmingdale Army Airfield, observing production techniques that were revolutionizing fighter aircraft manufacturing through systematic assembly methods adapted from automotive industry experience. As commander of the 8th Fighter Command, Kepner witnessed industrial capabilities that would soon challenge German assumptions about aviation production and pilot training limitations. The P-47 Thunderbolt program that Republic Aviation developed represented breakthrough achievement in fighter aircraft mass production through standardized design, interchangeable components, and assembly line manufacturing that enabled unprecedented production rates. American engineers had solved technical challenges that created reliable fighters suitable for systematic manufacturing. Aviation training systems that American military established included accelerated programs, systematic instruction, and standardized curricula that produced qualified pilots through efficient methods emphasizing practical competence over traditional long-term development. Democratic education created human resources adequate for massive aviation expansion. The civilian pilot training program that supported military aviation included college-based instruction, private flight schools, and systematic coordination that created pilot pipeline exceeding German training capacity. American educational infrastructure provided foundations for aviation expansion through competitive academic systems. Production coordination between Republic Aviation and supporting manufacturers included engine delivery from Pratt and Whitney, weapon systems from various contractors, and component supply from hundreds of subcontractors whose output was synchronized through systematic logistics management that exceeded German industrial organization. Training aircraft production paralleled fighter manufacturing through programs that provided adequate instruction platforms for pilot education without compromising combat aircraft availability. American industry achieved dual production that supported both training and operational requirements simultaneously. Quality control procedures throughout P-47 production ensured aircraft reliability through systematic testing, continuous inspection, and performance validation that maintained combat effectiveness while enabling mass production rates. Scientific manufacturing achieved quality through systematic methods rather than individual craftsmanship. The pilot replacement system that American aviation developed included systematic rotation, continuous training, and personnel management that maintained unit effectiveness while providing combat experience for new aviators. Human resource management exceeded German capabilities through systematic planning. International cooperation through P-47 programs included aircraft delivery to Allied forces while maintaining American operational requirements that demonstrated surplus production capacity. Democratic values created sustainable assistance that strengthened coalition aviation capabilities. Innovation acceleration continued throughout P-47 development as American engineers improved aircraft performance, manufacturing efficiency, and operational capability while maintaining production schedules. Competitive pressure encouraged continuous advancement that exceeded traditional development cycles. The economic efficiency that P-47 production achieved included cost reduction through volume manufacturing while maintaining performance standards adequate for combat effectiveness. Industrial competition created advantages through systematic optimization and competitive resource allocation. Strategic planning that incorporated massive P-47 deployment included tactical doctrine development, operational coordination, and logistical support that would maximize aviation effectiveness. American military strategy integrated production advantages into comprehensive campaign planning that assumed abundant aircraft availability. Training infrastructure supporting P-47 operations included flight schools, maintenance programs, and systematic instruction that prepared personnel for expanded aviation capabilities. Educational systems created human resources adequate for technological advantages while maintaining professional competence. The aviation miracle was creating fighter capabilities that would soon overwhelm German tactical advantages through systematic abundance rather than individual excellence alone, fundamentally altering aerial warfare through democratic production methods. June 6, 1944. D-Day operations over Normandy revealed devastating effectiveness of American P-47 deployment as Allied aviation achieved air superiority through systematic abundance that overwhelmed German tactical capabilities despite individual pilot excellence and aircraft quality advantages. The Luftwaffe faced fighter formations that seemed mathematically impossible according to traditional aviation calculations. The tactical deployment that P-47 operations achieved included multiple squadron formations operating simultaneously across extended frontages while maintaining tactical coordination that exceeded German response capabilities. American aviation had eliminated traditional aircraft limitations through systematic abundance that rendered individual tactical excellence strategically irrelevant. Hauptmann Richter found himself engaging P-47 formations that were immediately replaced by fresh squadrons when tactical situations required aviation support. American aviation abundance enabled continuous operations that exceeded German pilot endurance and aircraft availability, despite tactical competence and proven combat effectiveness. The operational tempo that P-47 deployment enabled included constant patrol activities, ground support missions, and escort operations that maintained Allied aviation presence throughout daylight hours. German forces faced aerial opposition that operated without traditional limitations imposed by aircraft shortages or pilot fatigue. Combat results from Normandy operations documented German aircraft losses that could not be replaced, while American P-47 units maintained strength through continuous reinforcement and pilot replacement. Mathematical relationships had shifted decisively in favor of Allied aviation abundance over German tactical expertise. Strategic implications of P-47 abundance included Allied aviation capabilities that could absorb tactical losses while maintaining operational effectiveness that exceeded German response possibilities. Quantity combined with adequate quality had achieved systematic advantages over individual excellence and technological sophistication. The psychological impact on German pilots included recognition that tactical victory could not influence strategic outcomes when facing aviation opposition that exceeded sustainable attrition rates. Individual combat success had become strategically meaningless against systematic American replacement capabilities. Intelligence analysis by German aviation commands revealed American aircraft production that included P-47 manufacturing exceeding total German fighter aircraft production, while maintaining simultaneous production of bombers, transport aircraft, and training planes. Enemy industrial capacity had achieved impossible abundance. Pilot training evidence from captured American aviators revealed systematic instruction programs that produced competent fighters through standardized methods rather than traditional long-term development. Democratic education had created human resources adequate for massive aviation expansion while maintaining tactical effectiveness. The maintenance infrastructure supporting P-47 operations included spare parts availability, repair capabilities, and technical services that maintained aircraft readiness under extended combat conditions. American logistics had created sustainability advantages that exceeded German resource allocation, despite homeland proximity. Communication coordination between P-47 formations included systematic tactical control, strategic coordination, and operational flexibility that enhanced aviation effectiveness while enabling rapid response to changing tactical situations. American organization exceeded German coordination through systematic command structures. Innovation integration throughout P-47 operations included continuous improvement in aircraft performance, tactical procedures, and operational coordination that exceeded traditional development methods. Competitive pressure had encouraged advancement while maintaining systematic production. The endless formations were demonstrating American aviation capabilities that rendered German tactical advantages obsolete through systematic abundance that exceeded any conceivable individual response, while proving that democratic industrial organization could achieve air superiority through production rather than excellence alone. August 1944. German intelligence analysis revealed American pilot training programs that challenged every assumption about aviation education and human resource development, documenting training facilities that graduated combat-ready pilots faster than German forces could eliminate them through tactical success. The systematic production of qualified aviators exceeded German understanding of educational possibility. The scale of American pilot training included over 400 flight training facilities operating simultaneously across the United States, creating educational capacity that exceeded total German aviation infrastructure, while maintaining standardized instruction that produced consistently competent pilots through systematic methods rather than individual excellence. Training aircraft production supporting pilot education included over 17,000 trainers manufactured specifically for instruction purposes, representing aircraft allocation that exceeded German total military aviation inventory while demonstrating American resource dedication to human development rather than immediate tactical requirements. Instructor pilot programs that supported American training included systematic development of teaching personnel through competitive selection and standardized curriculum that created educational capabilities exceeding traditional apprenticeship methods. Democratic education had produced systematic instruction that enhanced rather than compromised pilot quality. The civilian integration that American training achieved included airline pilots, private instructors, and aviation industry personnel who contributed to military pilot education through systematic cooperation. Democratic society had mobilized civilian expertise that enhanced rather than competed with military training requirements. Women's participation in American pilot training included ferry pilots, instructor pilots, and support personnel whose contributions enhanced training capacity while demonstrating democratic society's ability to utilize total population capabilities. Inclusive participation had multiplied human resources through competitive opportunity. International cooperation through American training programs included instruction for allied pilots, while maintaining domestic training capacity that indicated surplus capability beyond immediate American requirements. Democratic values had created sustainable assistance that enhanced coalition aviation strength. Psychological evaluation procedures that American training included systematic assessment of pilot aptitude, stress tolerance, and combat readiness that optimized human resource utilization while maintaining training efficiency. Scientific approaches to human development exceeded traditional methods through systematic evaluation. The economic efficiency that American training achieved included cost reduction through standardized instruction while maintaining pilot quality adequate for combat effectiveness. Competitive educational methods had created systematic advantages through efficient resource allocation and optimized training procedures. Technology integration throughout training programs included advanced simulators, systematic instruction aids, and standardized equipment that enhanced pilot education while reducing training time and resource consumption. American technological innovation had improved educational effectiveness through systematic application. Quality control procedures in pilot training ensured consistent competence through standardized testing, systematic evaluation, and continuous monitoring that maintained pilot quality while enabling mass production of qualified aviators. Scientific education had achieved reliability through systematic methods. Strategic planning that incorporated abundant pilot availability included operational doctrine that assumed unlimited human resources while developing tactical procedures that maximized pilot effectiveness. American strategy had integrated training advantages into comprehensive campaign planning. Medical support for training operations included health monitoring, psychological counseling, and systematic care that maintained pilot effectiveness while reducing training attrition. Healthcare advantages had improved human resource utilization through systematic medical support. The pilot factory was producing human resources that exceeded German elimination rates while maintaining quality standards adequate for tactical effectiveness, proving that democratic education could achieve systematic advantages in human development through competitive methods and inclusive participation that exceeded traditional training approaches. December 1944. As the Battle of the Bulge unfolded under clear skies, Klaus Richter faced his final aerial engagement against P-47 Thunderbolts that represented mathematical certainty rather than tactical possibility. American aviation had achieved systematic abundance that rendered individual German pilot excellence strategically meaningless through overwhelming numerical superiority combined with adequate tactical competence. The final statistics that accumulated through 1944 revealed American P-47 production exceeding 15,600 aircraft, while German fighter production declined under resource constraints and strategic bombing pressure. Mathematical relationships had shifted decisively toward Allied aviation through industrial capabilities that exceeded German response possibilities. Pilot replacement ratios documented through German intelligence revealed American training systems producing qualified aviators faster than combat losses, while German pilot casualties could not be replaced due to resource limitations and training infrastructure destruction. Human resource mathematics had become unsustainable for continued German resistance. The strategic validation that P-47 abundance provided confirmed industrial mobilization as decisive factor in aerial warfare, while demonstrating democratic advantages in resource allocation, technological development, and human education that exceeded authoritarian alternatives through competitive innovation and systematic organization. Economic efficiency that American aviation achieved included cost reduction through volume production, while maintaining tactical effectiveness that exceeded traditional aircraft development methods. Competitive capitalism had proven superior to command economy organization for systematic aviation development and pilot training. International cooperation through P-47 deployment included aircraft transfers to allied nations that enhanced collective aviation capabilities, while demonstrating American production capacity beyond domestic requirements. Democratic values had created sustainable assistance that strengthened coalition air power through systematic generosity. The educational systems that produced American pilots created human capital advantages through competitive academic development that exceeded traditional aviation training methods. Democratic education had produced tactical capabilities through systematic instruction and merit-based advancement that multiplied individual potential. Technological legacy of P-47 operations influenced post-war aviation development through manufacturing techniques, tactical innovations, and pilot training methods that revolutionized global aviation. Scientific advancement had created lasting advantages through systematic research and competitive development. Quality control achievements in mass production demonstrated American manufacturing capabilities that maintained tactical effectiveness while enabling systematic abundance that traditional methods could never achieve through individual attention. Scientific manufacturing had produced excellence through systematic approaches. The psychological transformation among surviving German pilots included recognition that individual excellence could not overcome systematic disadvantages created by democratic advantages in industrial organization and human development. Reality had challenged ideology through mathematical evidence. Strategic implications of American aviation dominance included post-war air power leadership that would influence global military doctrine through technological advantages established during wartime production. Democratic aviation had achieved systematic superiority that would shape international relationships. Innovation acceleration that P-47 development represented established American aviation industry as global leader through competitive research and systematic advancement that exceeded traditional development methods. Democratic innovation had created sustainable advantages through competitive excellence. Supply chain resilience that sustained P-47 operations included resource coordination and logistical management that maintained production despite global commitments. Systematic organization had achieved efficiency through competitive cooperation and democratic resource allocation. The mathematical certainty of defeat had been established through American aviation capabilities that proved democratic societies could achieve systematic advantages over individual excellence through competitive innovation, inclusive participation, and abundant production that authoritarian systems could never match through centralized control alone. If this incredible story of how American P-47 abundance overwhelmed German aerial expertise through systematic production amazed you, make sure to subscribe for more tales of democratic aviation triumph.